Hello builders, welcome back to the channel. Today we're going to be building a 1/14 scale version of a popular pull type pan or scraper, whatever you want to call it. Don't know how copyright laws really work. I'm not an expert in that field, so I'm kind of putting some tape over some branding. This is a popular pull type scraper. It's a 1/14 scale version of an 18-yard, 12-foot wide ejector style. The scraper has three functions on it. It has the pusher on the back that will eject the dirt out. It's got the door that raises up and down, so we have two linear actuators to control the door. A single linear actuator back in the back for running the pusher, and then we have two linear actuators up front for like the grade control of the blade. So this will be kind of a step-by-step build video on how to build this, the STLs and all this available on Cults 3D to purchase. And so we'll kind of go over the build process for getting through this thing. Just as a demonstration, we'll kind of look at some of the features. I'll hook them up to a power source. And so here's the door raise and lower. Then we've got the pusher in the back. We've got a little bit of obstructions on the with the bolts down there. I need to do a little bit of sanding on the bottom of this pusher. You can kind of hear it grinding a little bit. But we got a 3-inch stroke linear actuator in the back there, pushing that in and out. It's riding along some linear rails, and then there's also two bearing rollers in there as well. There is a cavity in the sidewall for running wires, so as we start to build this, we'll kind of go through all that. Put this door back. And then the final function is basically your up and down of the hitch. So raising and lowering. Also in the included will be a couple hitches for the ever so popular D6T built by Lass, which is available on Cults 3D, which is a really cool build under the profile Bernie 222, as well as I'll have a hitch for the Steiger from that North State comes out with, and then I'll hopefully make up some more hitches for other type popular dozers or tractors. So let's get started. So I won't bore you guys with all the mind-numbing video footage of installing a bunch of screws, but the first part of the build is assembling the base of it. And so the base in the files can be printed whole. My printer's not large enough to do that efficiently, so it's basically broken up into 3 sections, and then your wear plate on top there. So using some M3 self-tapping screws and some M2 self-tapping screws for the wear plate. So that's your first part, and then we're going to bring the sides in. And so our side plates, I'm using, and I'll skip around a little bit. If you follow the manual step by step, it might not be exactly how I do it in here, but it really doesn't matter. It's putting parts together. So these are the mounts for the lift cylinders. I'm using M2 self-tapping screws that are countersunk to give that a flush look. So I'm kind of showing these parts now, but before I start assembling, I'm going to prime them and paint them. And then the door, again, the door can be printed in one whole piece if your printer's large enough to do so. There is a file for this door complete, as well as in 2 halves, as well as these door braces. So the doors will be assembled with, I believe, about 30 M2 by 6mm self-tapping screws, putting the braces on, as well as assembling the door together. So then that's kind of what the door will look like. Our other big component is the pusher in the back. So the pusher will be assembled using 5 M2 by 6mm self-tapping screws. I as well plastic welded the backside using a soldering iron heated up to to basically heat that and just kind of help solder this along the back, or plastic weld it, fuse it together. I didn't do that along the front because this is where you're going to see, so I didn't want to kind of look as bad. But since you really don't see the back as much, it kind of helps, gives a little extra strength. But along the back here is where we'll mount the bracket for the linear actuator, or the pusher actuator, as well as putting some bearings in for the bottom of the pusher door. Again, you got a bunch of 3D printed components that we'll go over as we start to assemble this. But then this is your main beam with the main beam sides that get bolted on with 16 M2 self-tapping screws on each, 16 on each side. And so I got some of these basic pieces already assembled. All the rest of the stuff we'll assemble as we go, and so I'm going to go ahead and get all this stuff painted, then we'll start assembly. Alright, so I got all the parts painted, now let's start to put together. One thing I will mention is anytime you're using a self-tapping screw into plastic, depending on the quality of your printer, you may want to drill out the holes. So in the materials list I did mention that if you're putting in 2mm self-tapping screws, then use a 1/16 size drill bit or a 1.5mm drill bit. For 3mm screws, I use a 3/32 drill bit or a 2.25mm drill bit. Just so that the screws don't dig in too hard, and sometimes these inexpensive screws from China want to twist off. So we're going to use 8 3mm or M3 by 8mm self-tapping screws to screw the sides onto the base. So we'll kind of fast forward through this. Okay, so next step, once the sides are on, we're going to put the main beam in. You'll notice there's 2 holes on the outsides for the outside axle mount. There are 4 holes on the inside for that, and you'll notice if you turn it a quarter turn, there's only 2 holes where there's 4 on top. So those 2 holes go down. And so that will basically go in like that. Then we'll use 2mm by 6mm to screw this main beam to the sides. Okay, so once the main beam is bolted on, then the rear housing that will hold the linear actuator for the pusher door is going to go on next, but we need to mount the axle mounts to the side of it. And so these we'll just using 3mm by 8mm self-tapping screws, but before you want to put in, you're going to want to put in a 5mm lock nut that will hold the axle once we screw the axle in. So it's 3D printed and recessed for a 5mm lock nut. Put it in with the thread lock to what would be the inside. So when you think of a axle bolt going through, it'll screw in and then just get into the lock nut to hold it. So once you put those on, then we'll put those in here. They're not specific left or right, just either way. So we'll stick a lock nut right there and push it in there. You might need to clean that thread up just a little bit. So once the axle bushings are bolted onto the rear housing, then we're going to bolt the rear housing onto the main beam using 6 M3 by 8 screws up top and 2 at the bottom that will support the floor. Alright, so the next step is to moving on with the axles. We need to get our wheels and our 90mm OD tires. These are basically 10 scale 4-wheel drive tires. I really wish I could find more of a construction look tire, but really didn't find anything, so this is the best one I found. The link will be in the build sheets. So go ahead and get those tires popped on, and they fit pretty well. You will notice on the wheels when you print them, you have a nice smooth side that printed windows on top, and then a side that's more rough that was on bottom that was hooked to supports. So you want to, as you're assembling this, you want to put that rough looking side towards the inside where you're not going to see it nearly as prevalently, especially on this outside one. So repeat that 4 times, and then we have to install bearings, 5 by 11 by 4 millimeter bearings on both sides. So and sometimes you do have to take your X-Acto knife and clean up the inside a little bit for the bearing to pop in properly. You sometimes get that lip on there, so I'll usually just take a knife and scrape on the inside, maybe that extra paint you got in there, or when it printed, just kind of go in there and clean that up, and then we'll press the bearings in. So let's get these done. We'll get the tires mounted and bearings in. So for a threaded rod, we have we'll need 4 for axles and 2 for the hitch. We'll need 2 65 millimeters, 2 75 millimeters, and 2 45 millimeters. You can order just threaded rod in those links, or I just buy them in full links and then just cut them down. So I got the bandsaw here, and we'll do some cutting. So in preparing for doing the wiring on this, my electric actuator is going to be inside there. The wires are going to come out and run along the bottom of this cross member, and then they'll go into this cavity to work its way down along and up to the front. I haven't made this in the file, and actually I need to add that to a future vision of this cross member, but a couple holes in here so that you can screw on some little wire clips for wire management to screw on there. So at this point in time right now, I'm going to take just my little handheld drill and drill a couple holes in there to do that. But by the time this video is posted, I'll actually update that STL file with a couple small holes in here all along the back, so whichever way you want to route wires, that will be in there so you can put a couple small screws in. So now we'll put the tire on, and we'll put this inside axle brace on. The order is not extremely important. If you want to put the axle braces on, then put the shaft in later. But we definitely want to kind of get this on before you put the other one on. It makes it all just kind of a little bit easier getting these axles in place. So I'll just screw on the lock nut on this outside, and we'll attach this using M3 self-tapping screws. Now that the inside's done, we can start to work on the outside. So there is a right and left file, and you also notice these inside axle braces, there's a right and left. So your nice smooth finish put on the outside that you see, the more rough finish that had the supports on it will be on the inside. So then this rear axle brace will bolt to the side piece with 8 millimeter threads, and then we'll put a shaft through. The most difficult part is putting the nut on the back side inside here, but I usually just use needle nose pliers to hold the nut, start the shaft. But actually at this point in time, the outside shaft will be the 75 millimeter threaded rod, which I have sitting somewhere right here. I thought I had sitting, oh there they are, they rolled away. So I'll actually just put that threaded rod in here right now. So I'll take my needle nose pliers and hold the nut back there. And then start the shaft in, start the threaded rod in it. So now I can put the next wheel on. Put the outside axle brace on. I'll screw these in here, and then also hook the nut up. Also a note on this outside axle brace, you have the other part of the axle bushing that screws to the inside there using 2 M3 or the M3 8 by 8 millimeter screws. So that will go in there, and this can go on. When I put these linear rails on, I actually found some M2 by 6 millimeter, but they got a little bit bigger head on it. Not a real big head, but just a little bit bigger than the others. And these work really well for holding these linear actuators in there. And so I'll use every single one of those. Or I said linear actuator, these linear rails. But like I said, it's an M2 by 6 millimeter with just a little bit bigger head. I'm not sure if I put an actual link in there, because it looks like I ordered them by mistake. In some orders, sometimes I order these and it's a large head, sometimes I order and it's a small head. So maybe look for wherever you get your screws to see if they differentiate between those. And my phone just alerted me that my printer finished, which I kind of heard the thing finish there. So right now I'm printing one of the Bernie 222, or Lass's, the Kitten 394. So I'm printing the undercarriage of that. I'm sure most of you guys, if you're watching this video and are making this, you're very much aware of Lass's models. The Bernie 222 on Cult 3D. This honestly inspired me. The way he designed his models and how they work out, they're just awesome. I've been really impressed with his stuff, and I've done a lot of 3D printing, a lot of construction in the past, but I finally built this scraper with the mindset of build it how it's made in the real world, like the way that's assembled. Kind of going off how Lass's really upped the game when it comes to 3D printing construction equipment. And so, big fan of his work. I got a number of his models. I'm completing most of the whole Kitten line. I got the dozer, the payloader, the articulating dump truck, and doing the 394 now. So I'm a fan of the American brand construction equipment. And this will be pulled with my D6T. I also designed a hitch for that D6T, or DT6 I should say. We don't want to have get them in trouble with any licensing with any worm companies or kitten companies, whatever you want to call it. I think we all know what we're talking about. Okay, so moving on next. Again, waiting on the linear actuators to come in, so we actually could probably go ahead and put the door on. The door is basically put together in the two halves. I think we kind of went over that video already, or covered this earlier in it, and that will fit right down in here. It'll fit there. 2 bolts up top hold it, and then the linear actuator in there. These were all made so this inside hole is a little bit smaller, so you don't have to use a nut. It'll just thread right into it, as well as the linear actuator has a smaller hole on the inside, so that the screw will the M4 machine screw will go in and thread into the plastic. So no nuts required. Looking at that, actually I'll just refer back to my build manual for these size. Obviously it's an M4, but the M4 by, oh no, I'm sorry, on this I'm using M5 on top. So M5 by 20 millimeter, M4 is for the linear actuator. So let me grab my M5. And actually, I think I'm out of 20 millimeters. So I will take some longer ones and cut them down. Yep, I'm out of those. So I'm going to cut some down because I don't feel like waiting a week and a half on AliExpress to get some more. You know what? It'll just be a little long. That's all right. I think these are M5, but like, what are these? Yep, these are M5 to 23, and 20 is best for these. I'll go ahead and screw this in. Might as well pull the drill out. There we go. Then a linear actuator will hook up here to open and close the door. Also, while we're here, we can install the GPS mount. The GPS mount we'll install with some M6 screws. I also made up these little, this is actually called a Trimble Nav 900. I'm a Trimble dealer. This is the agriculture version of the receivers, and this is the kind of Trimble's newest globe that goes on pans for land leveling, land forming. And so I made me some Nav 900s. On my D6, I got the construction version of those MS 998s or whatever the current model is. I'm a Trimble Ag dealer. That's a construction product, but I'll put these on Colts as well. These little Nav 900s. So if you want to get the Trimble version, that can glue on the top of there as well. So we'll get that in a second. All right, we'll start on electronics. So as we get ready to mount all the linear actuators, it's best to kind of start add some length to the wire right now. So we have 4 25mm stroke linear actuators, 1 75mm stroke linear actuator. And when ordering the linear actuators, go for the slowest speed, highest torque. This stuff really doesn't need to move that fast. You don't need to open and close that door immediately, but you definitely want the power. So all of the actuators will have a rating of millimeters per second versus how many newtons of force it has, or newtons, newton meters, whatever. The N, you'll see, like these are 30 MMS with 30 millimeters per second travel. So it'll move every second 30 millimeters. And then like the force would be like, say, 32 N. And so you'll see some that are really high speed, like traveling really fast, but have a low torque, or high torque, low speed. You can't have high torque, high speed with this size motor. So a small little N30 motor like this, it's so many, it's either speed or torque based upon your gear reduction. So the 75mm actuator, I'm going to add approximately 24 inches of wire to this. So 24 inches is roughly 600 millimeters. No, that's not the exact equation or conversion, but I'm estimating. So I'm going to clip this off. We'll strip these ends and tin the ends, and then solder them to a length of wire about 24 inches or approximately 600 millimeters. That actually might be a little long, but I'd rather have long and then trim it off versus too short. Just got the soldering iron out. Here's my length of cable. And then I got some pre-cut pieces of shrink tube, just some really small stuff. I'll slide on there. This gauge of wire is just like, 22, 24 gauge wire, something like that. Just something about the same size, same diameter as the actuators. I ended up buying like 2 or 3 meters of this wire a year ago on a project I was working on, and it comes in handy. Let's go grab some parts. Okay, So I use my heat shrink to, or my heat gun to heat shrink the wires. So the long pusher actuator is now done. The next 4 actuators, 2 are for the door and 2 are for the lifting. The lifting ones, ultimately we're going to solder together and then solder a lead on to go to the hitch. And so these are actually too long of the leads, and so we need to take off approximately 5 inches off of them. And 5 inches is about 130 millimeters, so get to there and trim those off. So these 2 we will solder together and then solder a lead on at a later point in time in the build. So I'm going to set those 2 to the side. The other actuators for raising and lowering the door, we need to lengthen by about the length that we cut off the other servos. So actually, by about 5 inches would be sufficient. We need to lengthen these so that they can get all the way up around on the I was actually gonna, you can kind of see at the bottom of my screen here, so they can get all the way up and around there, because their standard length is not quite long enough. It's it's close. So actually the length that we just cut off these, we're going to use soldering onto those. Alright, we're going to go ahead and get this electronic actuator mounted, or the linear actuator for the pusher. I'm using an M4 by 30 millimeter machine screw. You can screw right in the back here. If you decide to do this before you put the tire on, you can. Otherwise, just kind of squeeze the tire in a little bit to get that started in there. So it can come in and out with the tire on and off. This will be a little hard lining up back there because it's kind of blind. Alright, so I got the linear actuator in there. Next we're going to route the wire. You can go either the right or left side, doesn't really matter. I'm going to kind of go down the left-hand side here. So I'll feed that down through this hole here, which will come out underneath this actuator for the door. So I'll pull that through. And then in the file you'll see some little cable clamps. And so there will be some holes on the back side of this rear crossbar. Okay. So I've got a couple cable clamps in there. Put that door down. Just to hold this wire up and out of the way, and then it'll come down inside that cavity there, so I'll kind of pull it tight. There we go. So now we'll put the linear actuators in for the door, and again these are the ones we added the extra length of wire to, so we'll use some M4 by 12s. And again, we won't need any nuts. These are basically, we'll screw straight into the plastic, and the wire will kind of put down below in that cavity. Okay. So now we have all those linear actuators in. We can start on basically mounting the main beam with the lift cylinders. So let me get a few things out of my way here. You know what? Let's put the pusher on. Should have had that on already. So we'll fit the pusher in place here. And the pusher is going to get attached to the bearings on this linear rail using 3 on each side. You're not using all 4 bolts. But using M2 by 6 millimeter machine screws. Some small little machine screws, 3 on this side, 3 on that side. And then we'll need to run this linear actuator out. Okay, that's good. And so the linear actuator gets installed with an M4 machine screw with the nut. You can use the one that was provided in the kit, or provided with your linear actuator. There we go. Let me go ahead and just retract this to get it out of the way. I keep a multi-voltage power supply. I can set it from 4 volts up to 12 volts. It's kind of handy just to have here when you need to run stuff. Okay, so that door is out of the way. The pusher is out of the way. The door is all hooked up. They're right now independent, so if I try to run them, I could run them individually. So let's move on to the next step, and that's starting to hook up the main beam. So we'll bring the main beam into play here. Now the main beam, it gets assembled. There's the main beam sides that get assembled with M2 self-tapping screws into the main beam itself. You'll notice there's 3 small holes. This is for the wire management cover on the main beam. That goes up. So make sure when you're putting this on, those 3 holes are up. The sides, let me grab one here, will basically come around the outside here and hook into here. Now there's a series of screws in the back side here. Don't set those yet, because angling this will be for your hitch. So different tractors or dozers or whatever may be different. And so the orientation of this is to basically set your ride height for the hitch. So this angle basically is going to be fixed. And so the way this goes together, you have 2 small holders that will hold the linear actuator. My original file, and some of you guys may have already built this, basically this is the mount for the linear actuator. One side will fit inside there. Might need to clean up that paint a little bit. But this goes on there, and that goes inside there. So let's put one of these together. There we go. And then that goes in there. And then the other one holds this on the outside here. And then this will slide in. And again, once you set your ride height, put some screws in the back side of this to hold this in place. On my first go around, like the first scraper I built, this is the design I used, and it works. You might have seen a video of it moving some dirt, but when the cylinder is all the way extended out, the scraper is basically touching the ground, and it raises up almost too high. And so I came out with another version of the linear actuator holder that the stem is just offset at 1/4 inch up, which will basically bring the linear actuator down, which won't allow this to raise as high, but it should allow you to cut down deeper. So I'm actually in this build going to try this second one, and we'll compare the 2 ride heights. So as you guys are putting yours together, you guys can see maybe which one you'd rather use. But we do look at it, the higher part of this thing will be up, and the shorter part, or the distance from the center pinion or trunnion mount to the bottom, will be down. So that will go there. That will slide on the outside here. These go on here. So I'm going to go ahead and set the screw. These are going to be M5 screws that will be attaching this side to basically these 2 sides together. So it is M5 by 15 millimeter. Get my M5 container out. And again, no nuts required. They'll just screw into the plastic. I might as well get my linear actuator while I'm at it. So I'll grab one of these. And these should be pretty well tight enough that in the way that the force is put on, I'm not attaching this to this in any way. I'm not gluing it. It just slides in there. It's kind of a press fit, and I've not yet had trouble with that. So in the way the force is, it's a pulling action against here, so there's really not pushing the actuator up out of there, it's pulling it down in. So I've not had to attach that in any way. So I just kind of slide them down in there and then hook this up. Let me go ahead and turn this around. Now, I'm getting this. I need a bigger desk, and I need a more organized desk. Actually, if I made a bigger desk, it would just still be unorganized, just like this is now. I always have too many irons in the fire, too many projects going on. Okay. All right. So, tools out of here, man. Pull some wires down. If you've not worked with linear actuators before, it's literally just a positive and negative feed. So put power to it, it runs one way, reverse the current, and it runs the other way. And there's internal limit switches that don't allow them to run too far. So now we're going to use an M4 screw. It's probably going to be about 15 millimeter or so. Let me go ahead and look it up here. Yeah, M4 by 18 millimeters. Okay, I got this hitch blocked up right about where I want it. This wall plug is just within about 1/8 of an inch of the height I want. So I got my linear actuators in their mounts set where I want them, and like this is where I like it. So instead of putting all these screws in right now, I'm just going to put one in for right now, get the whole thing hooked up to the tractor. If I like it, then I'll put the rest in. If I don't like it, I'll take that one screw out and then rotate this up or down to where I want this. So you can see how with everything set here, you basically move this to the right height of your tractor. You want to look at your actuators up and down so you know you're getting the full range you want. Like if you want this to dig down some, you know, by raising this up would let that dig down deeper in the hitch. So I'm going to set this right here, and I'm just going to use my small little handheld screw drill. You'll also want to look at the spacing or the gap on this here. We want this sticking out about 1/16 of an inch or just a millimeter or two. It's just going to stick out just a hair, and so I'm going to do that just like that. Okay, so now some M3 machine screw or M3 self-tapping screws. Oh, by about 10 millimeters would be sufficient for these. So now that we got the actuator mounted again, I'll test this with my tractor, and if this needs to be raised or lower, I can take these screws out and rotate this up or down to adjust the right height. Now we'll put the hitch together. We'll need 4 of the 5 by 11 by 4 millimeter bearings, the 2 45 millimeter threads, and 4 lock nuts. So we'll put the bearings in each half of the coupler to hit. And again, depending on the tolerances of your printer, you may need to take an X-Acto knife and just clean up the edges on the inside so the bearings fit in there nicely. Here's my makeshift bearing press. I would kind of like to get like a little mini arbor press. And this is more going in a little bit stiffer just because of the paint that's inside there. So, but the bearings are in. And so we'll put one of the rods through vertically, clean those up. Let me clean these out just because the paint buildup on the inside doesn't allow the rod to go through smoothly. So actually I just chucked the threaded rod up into the drill so I can basically just kind of screw it in. Goes a little bit easier. then we'll install the two lock nuts, one on top and bottom. So there we go, that's in there, and this swivels nice and freely. Next we need to install the front part of the hitch, so we'll get the other 45 millimeter. We can kind of start a lock nut on there. Then you'll notice inside this cap, as well as inside the front part of the hitch, is a recess for the same dimensions as a 5 millimeter nut, so that it will you can actually use the hitch as kind of like your nut as you're screwing it in, or it'll sit kind of recessed in place. Oh, yeah, and I'll just drive. Drove the threaded rod into the nut a little too far, so I'm backing the nut out, because you don't want that sticking through too far, because it might get interfering with the hitch. So then that'll go through there, this will slide through there, and then we'll install this the nut with the backing cap on there. So stick a nut inside that backing cap, slide that into place, and then screw that in. And then we'll have a hitch put together. We'll need to get a 5 millimeter by 30 millimeter machine screw through there. And the hole is, you'll notice the hole is smaller on one side versus the other, so you can just screw the bolt right. But we'll screw that together, and that will be our hitch. This angle part will be on the top, so it'll kind of angle down, and then this will get bolted to our main beam. Next thing I'll grab is that hitch that we put together earlier, and this will slide into here, and we'll use 4 of the M3 by 20 millimeters. Okay, so now we have our hitch, our lift actuators. The only thing I hadn't put in yet is the GPS arm. So I kind of talked about that earlier. GPS antenna will stick up there, and the arm will come in with just some M2 self-tapping screws. Turn that the other way, so the clean side is up. So M2 by about 10 millimeters. So let me go and put those in. So now I got the GPS mount in. Everything, basically the scraper's about done for the base part of it. The last kind of couple things we have is the wire management. And so the wire management comes in 2 halves or 2 parts. And so we'll screw this base down using, again, some M2 self-tapping screws. They can be short ones, like a couple by 6 millimeter. Don't need to be real long here. They're just holding these things down, this thing down on top. And that's what those 3 holes are for in the print. Okay, and then this cover can go on top, hiding most of our wire connections. So let's finish up the wiring now. So we have the wires for the linear actuators for the doors, and they can just come through these holes, and that's kind of what will hold everything together. So this needs to come through here as well. And these 2 will get soldered together, and 1 lead running up to the tractor. We also have the wire for the actuator door for that side. These 2 I'm also going to cut and solder together, and that will run 1 lead up to the tractor. And then we have our long lead for a pusher. This will also come through here. But before I do all of that, I've got some, I was just sitting here. Where to go? I had it sitting here, I pushed everything around. Grab my bag of it. Some 1/8 inch spiral wrap, and so this stuff widens out really wide. I like covering all my wires in this so you don't kind of see that red and green look. Commonly you'll see hose wrap that looks like this for hydraulic hoses on a lot of stuff. So there is a link on the Colts page. I originally didn't put it in that materials list, but someone made a comment like, hey, where'd you get that? And so they put a couple links in there. So I'm just going to cut me off here a couple feet or so. Get this out of the way. And then I'm going to start wrapping the wire all the way back in here, up and around. And this wrap, along with the wire, kind of allows it to kind of stay hidden and stay in its place. And so you really don't need to add a whole lot of cable ties. Now if you want to add some more cable clamps down along here, to keep it held up. But once you get this one in here, it stays in there pretty good. So I'm going to go add the wrap, and then we'll come back to solder this stuff. Okay, so I got the wrap put on. I also put a couple small zip ties on these to hold them together. Got the wires fed through here. These are my lifting actuators. These are my door actuators. I got them kind of hooked together, got them soldered together. Now I'm going to solder on the leads for the extensions to go down to the hitch. So I got, again, about some 12-inch long, approximately 300 millimeter leads. Actually, earlier in the video I said a 10-inch long, but make them long, then you can always cut off what's extra. It'd be bad to make it too short. So let's solder these on here. We can run that down through the middle as well. I'm going to put one more zip tie just on this here to kind of keep them held in together. So like zip ties, heat shrink, this wire wrap is just standard supplies I keep in here. There we go. Now we can put this cover on to hide the wires. And just use 3 of the M2 by 6 millimeter self-tapping screws. So now I'll go ahead and wire wrap all these wires as well, just to kind of, again, give them a nice clean hydraulic hose look. And then right now I'm not for sure which one's which of these, so we'll cut these all off to the same length, and then we'll solder the banana connectors on them, and then I'll identify which one's which. So let's get these soldered. Okay, so I got the banana connector soldered in, heat shrink covered them up, and got some wrap around all this, and just use some little jewelry chain to kind of hook it to this top link up above. So the basic of the scraper is done. I am going to apply the decals. So I wish I had one of those professional silhouette cutters. I don't have one of those. I've stolen my wife's Cricut. And so attached to the files are some PDFs and some images of the decals with dimensions that you need to size them as, so whatever program you're using in. So this Ashley logo will go right here along the side, kind of parallel in this alignment. There's a small A logo that will go in here. And so when this is sitting down and on the hitch, this is horizontal. The E1218 is going to go right up here above the door actuator, and then the larger A logo is going to go right back in here. So let's go ahead and put some logos on. Now repeat your logos for the other side, and you are complete. So hopefully you guys enjoyed this build, and hope to see some posts on Facebook and see some pictures of these of your guys' own build. So thank you very much. Have a good day.